Welcome to Signal Science System subject classes. Now we are in the 7th chapter, that is Laplace transform. So in previous class, we discussed about Laplace transform and inverse Laplace transform and the importance of the ROC, region of convergence. And also we discussed about unilateral Laplace transform, the difference between unilateral and bilateral Laplace transform. Unilateral, the limit starts from the 0 to infinity. In bilateral, we should take the limits from minus infinity to plus infinity. This is a major difference between unilateral Laplace transform and bilateral Laplace transform. So this is the ninth video. So part 9th. So in this class, we are going to discuss some problems. These are collected from the engineering service examination, which is being conducted by the Union Public Service Commission. So the function f of t is given. So we have to find the Laplace transform for this given function. But the function it is given in the graph. So we need to write this graph in mathematical. For that, see, this is f of t. F of t equal to, so this is a ramp. It is a ramp from the 0 to 1 only. So the ramp, the t into e of t, that is must to be multiplied by the, this is a rectangular part which is having the magnitude 1 and from the 0 to 1. So simple, this is ramp. See this ramp. So in this case only from 0 to 1, t must be multiplied by the rectangular pulse, that is u of t minus u of t minus 1. So for this case, this is this is ramp from the 0 to 1. Then remaining, here we have rectangular pulse which is having the magnitude 1 and width that equal to 1 unit from 1 to 2. For that is u of t minus 1 minus u of t minus 2. So this is u of t minus 1 minus u of t minus 2. So this one is t into u of t minus u of t minus 1. This is the case. So in expansion, t into u of t minus t into u of t minus 1 plus u of t minus 1 minus u of t minus 2. So this is okay. We can convert time down to frequency, but here this is u of t minus 1 is multiplied by t. Here u of t minus 1. Then for the convenience, I am writing like this. Minus, I am taking u minus u of t minus 1. Then I will get t here, t and minus 1 minus of u of t minus 2. So here t into u of t and minus t minus 1, it is multiplied by the 1 unit delay in the unit step minus u of t minus 2. So this is the case. This is f of t. Now apply Laplace transform on both sides. F of s that equal to that t Laplace transform that equal 1 by s square minus say t into u of t Laplace transform 1 by s square. So this is delayed signal. For the delay time delay minus s into t naught equal to 1. So only we will get e power minus s by s square. Then now this is only simple impulse, unit step delayed by the 2 unit. So e power minus s into t naught equal to 2. So 2s by, so unit step Laplace transform equal to 1 by s. Take s square is 1 by s square is a common. 1 by e power minus s minus 2s. So e power minus 2s. So this is the f of s. So simple. So the option is, see, sorry, there is no 2. There is only s only. E power minus 2 is okay. Option D. The next problem, the output of a linear system to a unit step input u of t is t square e power minus 2t, the system function h of s. We know that LTI system, for the LTI system, so LTI system in S domain, this is called h of s, transfer function, input x of s, this is output y of s. So h of s is asking a transfer function, system function. So h of s, that equal to y of s by x of s. So here unit step is given. So x of t, that equal to u of t, and y of t is given. So that y of t equal to t square into e power minus 2t. So first x of s, so thus x of x, that equal to 1 by s. Then next y of t, so that equal to t square into e power minus 2t, 2t. So we have the formula t to the power of n minus 1 by n minus 1 factorial into u of t, that equal to e power, sorry, so that equal to, so that equal to 1 by s to the power of n. So e power minus 2t, it is multiplied, then t to the power of minus 1 by n minus 1 factorial. So e power minus at into u of t, it's a Laplace transform, that equal to 1 by, so s plus a to the power of n. So for the Laplace transform y of s, that equal to, so 2 factorial. So this is power 2, 2 factorial. So this is 2 factorial. So I'm sending the, so we can write this is n minus 1 factor also. We can send to the right side also. So for that, 2 factorial is nothing but 2, 2 by, so s plus 2, s plus 2, that equal to, here n minus 1 equal to 2, so n equal to 3. So h of s equal to 2 by s plus 2 to the power of 3 by 1 by s, that equal to 2s by s plus 2 power of 3. So this is it. So 2s, so option D. Next one, next problem. The relationship between the input and output is given. The transfer function same. See, so d square y by, so dt square, that equal to x of t minus 2 e of t minus 2 plus d square x by dt square. So apply Laplace transform on both sides. So this is s square y of s. So this is x of s. So x of s, here this is x of s. So this is delayed. So we should multiply with e power minus 2s plus, so s square into x of s. So x of s is the common. So s square plus e power minus 2s. So y of s by x of s that equal to h of s that equal to s square plus e power minus 2s by s square. So it is nothing but 1 by 1 plus e power minus 2s by s square. So this is 1 plus option B. Next question. The given Laplace transform that will f of s, f of t. So which of the following expressions are correct? See the Laplace transform of f of t minus a u of t minus a, already in previously we applied this one. So that is equal to f of s into e power minus. So this is delayed signal is delayed signal. So this is the correct statement. And t into f of t already, so t into x of t, so that equal to in Laplace transform it is called differentiation in the frequency domain, s domain. So this is minus d by ds into f of s. So it is also correct. And t minus a into f of t. So it's a Laplace transform. Before writing t into f of t minus a into f of t, so it's a Laplace transform equal to t into f of t. So this is minus d by ds f of s minus a into f of s. So this is wrong. Coming to the differentiation in the time domain, so we know that so d by so in see in so x of t, for example, in x of t, it's the Laplace transform equal to f of s, sorry, x of s, and so d by dt of x of t, it is nothing but s into x of s, is it? So for the this is the property for the bilateral, but in case of the unilateral, so in unilateral d by dt of x of t, so that is equal to s into x of s minus initial value, is it? This is in the case of the unilateral. So this is in case of the bilateral. So already here given that the Fourier transform or the limits values, see, so this is from the 0 to infinite. So these are the given the expression, it is for the unilateral Laplace transform. So for the unilateral Laplace transform, this statement is wrong. Okay. For the bilateral, it is a correct. So very be careful. If you're not concentrated on the limit values, then the option will be 1, 2, and 4. There is a option 1, 2, 4. But it is given Laplace transform is a unilateral. For that, 1, 2 only correct. So option C. So this is very important. Be careful while um, attempting the questions in case of the Laplace transform. You have to check it. So yeah, whether it is a unilateral Laplace transform or bilateral Laplace transform, there is only one property is difference between the bilateral and unilateral. That is the differentiation property, differentiation time domain. So in the bilateral, the differentiation property just y of x of s. Sorry, this is x of s. So x of s is multiplied by the s only. But in case of the unilateral, you should take the we need to consider the initial value. That is a major difference. This is a note. The next one, Given that one x1 of t is given, x2 of t given, which one of the following gives their convolution? We done this convolution in the second chapter, also. But in the second chapter we learned the solving the convolution with the help of the graphical method. But in Laplace transform also we can solve this convolution also. It's but graphical method it takes more time. Okay. So now, so the given the given x1 of t that equal to e power k1 t into u of t, and x2 of t e power minus k2 into t u of t. Now for we need to find x1 convolution x2. So so in the frequency domain, so in S domain, so that equal to x1 into x2. So that equal to, so Laplace transform that equal to 1 by s minus k1 into x2. So that equal 1 by s plus k2. Now apply partial fraction method. So in the partial fraction method here, so there, in numerator there is no s, so we have to do the subtraction. So s minus k1 minus 1 by s minus k2. See, so we'll get k1 minus k2, k1 minus k2, or we can also write like 1 by s minus k2. See, do that. And first, I want to take 1 by, sorry, okay, 1 by s minus k1 minus 1 by s plus k2. So then, so this is equal to k2 minus k2 minus into minus so plus k1 by s minus k1 into s plus k2. So in our problem, so 1 by s minus k1 into 1 by s plus k2, we can write it is equal to 1 by k2 plus k1 in the partial fraction 1 by s minus k1 minus 1 by s minus s plus k2. So this is the partial fraction is a shortcut. By practicing, you can get easily. So now apply inverse Laplace transform for this inverse Laplace transform. So 1 by k2 plus k1 is a constant. So this is e power k1t into u of t minus e power minus k2 t into u of t. So this is inverse Laplace transform. So that is e power k1t minus e power k2t by k2 plus k1. So the answer is option A. So the next problem, the Laplace transform x of s of a function x of t is given. What is the wave shape of the x of t? So Laplace transform is given. So x of s that equal to, so 1 by s minus e power minus s into t by s. So inverse Laplace transform on both sides, then x of t equal to, so this is u of t and this is u of t minus capital T. So this is rectangular pulse. So u of t minus u of t, so this is option C. You can write. So this is T. So option C. So a voltage having Laplace transform, this voltage is given V of S that equal to 4s square plus 3s plus 2 by 7s square plus 6x plus 5 is given. Is applied across a 2 Henry inductor having zero initial current. What is the current in the inductor at t equal to infinity? He is asking current I at infinity. That equal to for the final value theorem. The final value theorem it says that so limit s tends to 0 s into I of s. So the relation between the inductor, so V of s equal to s into sorry, so Ls into I of s. So this is the inductor impedance. So L is so we need s into I of s. So L equal to 2. So s into I of s that equal to V of s by 2. Then so limit s tends to 0. So 1 by 2 and that V of s. So 4s square plus 3s plus 2 by 7s square plus 6s plus 5. Substitute s equal 0, 1 by 2, 2 by 5. So that equal to 1 by 5 amperes. So option B. Laplace transform of the function f of t shown in the figure. So this is triangular waveform. So we know that triangular waveform. So we need to find Laplace transform for this triangular. So actually I know that the convolution between the rectangular pulse it gives the triangular. See here I'm taking rectangular pulse. So this is here this t equal to 1. So this is the 1 by 2. So I'm taking the width equal to 1 by 2 rectangular. So 1 by 2 t and this is x of t magnitude equal to 1. So it's a convolution. So it is also 1 by 2 same signal. So x of t. So it's a resultant signal in time domain. So this is 1 by 2 1 and t. So this is x of t convolution x of t. So here this magnitude equal to 1 by 2. So it's very important. The slope equal to 1 unit. So the magnitude 1 by 2. So 1 by 2. So that 1 unit. So this is a, so I'm assuming this is f of t. So the Laplace transform of this it is equal to Laplace transform of the this convolution. So that is so Laplace transform of that f of t, this f of t that equal to Laplace transform of convolution between the x of t convolution x of t that equal to x of s into x of s that equal to x square of s. Now the x of t signal is nothing but e of t minus e of t minus 1 by 2. So it's Laplace transform x of s equal to 1 by s minus e power minus s by 2 by s. So that equal to 1 minus e power minus s by 2 by s. So the Laplace transform f of t that equal to 1 minus e power minus s by 2 by s whole square to square. But in given function, the magnitude is not given. So this is given like a 1. So this is we can send to the this side also. So now this is sent to this. So the given function. So this is I'm assuming this is f dash. So Laplace transform of f dash of f of t that equal to 2 into 1 minus e power minus s by 2 square by s square. See, for this function, so here we should write 1 by 2, but here he has taken this magnitude 1, so we can send to the left side. So answer is, so 2 by 1 minus, so this is the place and option A. The system described by the following differential equation initial at rest and then excited by the input that equal 3 into v of t, then the output y of t is. So first we should find the y of s, then apply inverse Laplace transform, then we will get the y of t. So d square y by dt square plus 4 into dy by dt plus 3y equal to x. Here x equal to 3 into e of t. Substitute x of t. Then apply Laplace transform that equal to s square y of s plus 4 into s y of s plus 3 into y of s 3 into that equal to 1 by s. So y of s, so that equal to 3 by s. So common. So that equal to s square plus 4s plus 3. So y in factors we can write in factors. So 3 s plus 3 and s plus 1. In partial fractions, you can write 3 is right. So s equal 0. Substitute s equal 0. 1 by, so 1 by we will get 3 by s. And for the in case of the s plus 3, substitute s equal to minus 3. Leave the 3. We have taken the 3 is a common. So s equal to minus 3. So 1 by, so s equal to minus 3. So this is minus 3 and minus 3 minus 1 that is equal to minus 2. Next, s plus 1, substitute s equal to minus 1. 1 by s equal to minus 1 and here minus 1 plus 3 that equal to 2. So this is 3. So take the 3. So that equal to we will get 1 by s. So 3 into 1 by 3 gets cancelled. Now this is minus 2 minus plus 1 by 6. So here we will get 1 by 2 into s plus 3. Next minus 2, that is 3 by 2. So 3 by 2 s plus 1. Now apply inverse Laplace transform. So y of t equal to this is e of t and this is 1 by 2 e power minus 3t e of t. So this is minus 3 by 2 e power minus t into e of t. So this is the answer. So e of t minus, yeah, minus 3 by 2, so and plus 1 by 2. So this is option E. So 10th problem. Here, consider the system with the transfer function. The step response of the system is given. Step response. So h of s that equal to y of s into e of s. We can take input is x of s, no problem. X of s. So y of s is asking unit step. So h of s into x of s. So h of s equal to 3s square minus 2 by, so s square plus 3s plus 2 into x of s equal to unit step 1 by s. So again we need to apply partial fraction, that is s. So here also the factors are s plus 2 and s plus 1. Again now for the s, so s equal 0, substitute s equal 0 in the whole, so s equal 0 in numerator, so minus 2 by, so here s equal 0, 2, 2, 2. Next, plus s plus 2. Now substitute s equal to minus 2 in whole function. So minus 2, 3 into minus 2, 2 to 4, minus 2 by here minus 2, minus 2 and minus 2 here minus 1. And next s plus 1. Substitute s equal to minus 1. So 3 into 1 minus 2 by s equal to minus 1 here, minus 1 here. So minus 1 is equal to 1. So now, so minus 2 minus 1 by s, and 4, 12 minus 2, 10, 10, and minus into minus plus, plus. So that equal to 5 by s plus 2, and 3 minus 2, 1, so minus 1 by s plus 1. Apply inverse Laplace transform. So that equal to, so y of s that equal to minus u of t plus 5 into e power minus 2t e of t minus e power minus t into u of t. So this is the answer. So 5. So option A. Now the unit step response y of t is given. Y of t is given for the system function, the frequency at which force response becomes 0. The function will be 0. So this y of t is given. So the y of t equal to 1 minus 3 into e power minus t 3t plus 3 into e power minus 2t, so into overall u of t. So first we need to find the s domain function. So that equal to u of t Laplace transform 1 by s minus 3 by s plus 1 plus 3 by s plus 2. So take the LCM. So in here we will get so s plus 1 into s plus 2 minus 3 into s plus 2. Here 3 into s plus 1. So in numerator must be 0. So that's why I'm not taking the denominator. So it must be goes to 0. For what value it goes to 0. That is the concept. So s square, here expand is s square plus 2s plus s plus 2 minus 3s square minus 2 into 3, 6, 6x plus 3s square plus 3s that equal to 0. So, this 3s and this 2s, 3s, 6x, it gets cancelled. This 3s square gets cancelled. Now we're getting s square plus 2. Now he is finding frequency. So substituting j omega whole square plus 2 that equal to 0, j square equal to minus omega square that equal to minus 2, minus 1 gets cancelled, omega equal to root 2. This is radians per seconds. So option C. Now the unit impulse response of the system is given. The step response of the same system for is, so this is impulse response, this is step response. Then so A, B, and C are respectively. So this so unit step response for the Laplace transform, the unit impulse response is nothing but transfer function. So h of s that equal to, so h of s that equal to minus 4 by, so s plus 1 plus 6 by s plus 2. Next, it's a transfer function. We know that actually unit impulse response, so unit step response that equal to integral of integral of impulse impulse response, unit impulse response, is it? So for the integration, here we will get 4 into e power minus t and minus 3 into e power minus 2t. For the comparison, here we are understanding that a equal to 4, b equal to minus 3. So now we need to find the c value. So the second one, the unit step response. So y of s is given that equal to, here I am writing a equal to 4. So 4 by s plus 1 plus b equal to minus 3, minus 3 by s plus 2. So here plus c by s. So this is a unit step response. Then h of s equal to, so h of s equal to y of s by 1 by s. So first you write y of s that equal 4 into, so s plus 2 and s, so minus 3 into s into s plus 1 plus c into s plus 1 and s plus 2 by s into s plus 1, s plus 2 by 1 by s. So s gets cancelled. So this h of s, so that equal to, here we will get c value, compare, so 4 into, so 4 into s into s plus 2 minus 3s into s plus 1 plus c into s plus 1 into s plus 2 by, so s plus 1 and s plus 2. See, so this both are same. This h of s and this s of is same. So in after simplification in numerator we will never get the s square coefficient. So here s square coefficient equal 0. For that, I am equating this s square coefficient for from this equation and this equation. So s square coefficient, s square, here we will get 4 and here minus 3 and here we will get to c. So 0, 1 plus c, so c equal to minus 1. So this is the concept. So the option is 4, a equal to 4, b equal to minus 3, c equal to, we got minus 1. So this is the answer. The next problem. So Laplace transform of the function v of t shown in the figure. So the v of t equal to same the ramp signal. This ramp signal t into u of t minus u of t minus 1. Then this is the unit step delayed that equal to t u of t minus 1. Here t into u of t we have. So this is so for that this is 2 into u of t minus 1 to u of t minus 1. So here this is shifted, but is here t is not shifted. So for that, for the convenience, I am writing like this. Minus, I am taking the minus u of t minus 1 is a common. Then you will get t minus 1. So now, so this is 2 t into u of t. So this is in overall function also shifted signal. T minus 1 and here also t replaced by t minus 1. Now apply Laplace transform. So that equal 1 by s square minus here also 1 by s square, but for the shifting we need to write e power minus s into, for delayed e power minus s into t naught equal to 1. So then yes, so 1 minus e power minus s by s square. So this is the 1 by s square 1 minus e power. So option D. So next problem, a function C of t satisfies the differential equation for the zero initial conditions. C of t can be represented. So d by dt of C of t plus C of t equal to del of t. We need to find the C of t. So Laplace transform s into C of s plus C of s. So that equal 1. So C of s common 1 plus s that equal to 1. So C of s equal to 1 by s 1 plus s. So that equal inverse Laplace transform. So C of t that equal to e power minus e power. So here a equal to 1. So 1 into t into u of t. This is the case. We can also solve this one from the mathematical first order differential equation solution that equal to d by dx y plus py that equal to q. So p and q are function of x. So that is it's a solution. It's a solution in mathematical is another method. So this is another method without applying the Laplace and inverse Laplace. So this is a solution actually. Uh, so this is its solution that equal to y into integral factor, that integral factor equal to e power integral of p into dx. So that equal to integral of, so q, this is the p, the q into integral factor that equal to e power integral of p into dx. Then this is the dx. So this is the solution for the this is the first order. It's called first order differential equation. First order linear differential equation. Differential equation. For in this also we can solve this one. So the answer is e power minus t into u of t. Last problem. See, if is the Laplace transform, then f of 0. This is initial value theorem. Initial value theorem. So x of 0 plus that equal to limit s tends to infinite s into x of s. So similarly, f of 0 plus that equal to limit s tends to infinite s into, so f of s that equal to 27 s plus 97 by, so s is k plus 33s. So this is limit. We can write 1 by s tends to 0. So s is k common. Then 27 plus 97 by s by 1 plus 33 by s. So it goes to 0. Then we will get 27. F of 0 plus that equal to 27. So option is C. So these are the problems from the engineering service examination in electronics and communication branch. So in next class, we will do the revision of the Laplace transform. Thank you.